In our search for life, we often look deep into the cosmos, never suspecting it might be much closer than we think. What if aliens aren't hiding somewhere out there, but right here, on a planet almost identical to Earth? A place that at first glance seems utterly dead, where acid rain falls from the sky and lead-filled clouds melt in the scorching heat. The planet Venus. Could there really be life there? It all began in the 1970s, when the Soviet Union launched several successful space missions under the name Venera. At the time, astronomers around the world were passionately debating whether a habitable surface might be hidden beneath Venus's thick cloud cover. After all, the planet is strikingly similar to Earth. Its radius is only about 5% smaller, and gravity there is almost the same. The data collected by Soviet scientists, however, painted a puzzling picture. Venus turned out to be a blazing inferno, with surface temperatures reaching up to 470 degrees Celsius. But there was one intriguing detail. At an altitude of about 60 kilometers, the temperature drops to a far more tolerable 30 degrees Celsius, and the pressure becomes roughly equal to that on Earth. For several years, this discovery stirred the scientific community. But when the Soviet program was discontinued and Mars began to look like the more promising candidate, Venus quietly faded from attention. That changed in September 2020, when an international team of researchers led by Jane Greaves from Cardiff University announced a shocking discovery. Using the JCMT radio telescope in Hawaii and ALMA in Chile, they had detected phosphine in Venus's atmosphere, a gas that on Earth is almost exclusively produced by microorganisms that live without oxygen. It was like hearing a faint whisper from a neighboring hell. Phosphine is not something that forms easily through natural chemical processes. On Earth, it appears either as a result of industrial activity or as a byproduct of microbial life. The scientists reported that the concentration of phosphine in Venus's clouds reached about 20 parts per billion, and more importantly, that no known non-biological process could account for that amount. Suddenly, the thought of nearby life resurfaced in the minds of scientists around the world. After decades of searching on Mars, Titan, and Europa, all eyes turned once again to Venus. Interest in the discovery grew even stronger when scientists remembered that back in 1967, even before the Soviet Venera missions, astronomer Carl Sagan and physicist Harold Morowitz had suggested that Venus's clouds might host floating microbial communities. They described them as a kind of aerial plankton, capable of feeding on sulfur and ultraviolet light. At the time, the scientific community dismissed the idea as pure science fiction. The problem was that back then, science hadn't yet discovered extremophiles, organisms that thrive in acid, inside nuclear reactors, in the depths of the ocean, at 120 degrees Celsius, or even without oxygen. That's why the 2020 Venus data, combined with the old Sagan-Morowitz hypothesis, reignited serious discussion and raised fascinating new questions. First, could these hypothetical microorganisms have originated within Venus's harsh environment, or did they survive from an earlier era, remnants of a time when Venus was an oceanic planet, before it turned into a greenhouse inferno? If so, they might be the descendants of an ancient biosphere that evacuated upward into the clouds when the oceans boiled away. But the deeper question went beyond Venus itself. It challenged our very understanding of what we're searching for. Have we ever truly looked for life in the universe, or only for life that looks like us? When we search for other civilizations or organisms, we tend to project our own traits onto them, our chemistry, our biology, even our breathing. What if life on another planet doesn't breathe like us, eat like us, or interact with its environment as we do? Pop culture has conditioned us to imagine humanoid beings, partly familiar, partly alien, but still somehow like us. And in that sense, we might even feel disappointed if our cosmic neighbors turn out to be nothing more than anaerobic bacteria. The same applies to how we search. Maybe we'll never find extraterrestrial life, not because it doesn't exist, but because it doesn't look the way we expect it to, or because our tools simply aren't built to recognize it. Today, NASA views the 2020 findings with considerable skepticism. Their follow-up analyses of Venus's atmosphere failed to confirm a sufficient amount of phosphine to support the idea of microbial life. Some researchers even argued that the original signal used to detect phosphine was likely misidentified. It might have actually been sulfur dioxide, a far more common gas on the planet. And while the ALMA telescope is an extraordinarily sensitive instrument, working with such faint spectral lines requires perfect calibration. Still, the results can't be fully dismissed. For one thing, potential microbial colonies could be small, and their movement, or even shifts in Venus's own atmosphere, might distort later measurements. Some scientists have gone back to re examine data from the old Soviet Venera missions and found intriguing signs of their own: sulfur gradients and mysterious ultraviolet absorbers in the upper atmosphere, substances that seem to change the color of Venus's clouds. Despite its public caution, NASA hasn't closed the door on the possibility of life on Venus. The agency believes that a definitive answer can only come from new missions that study the planet directly. Two of them, Da Vinci Plus and Veritas, are already in development. Da Vinci Plus will send a probe descending through the clouds, measuring gas composition and pressure along the way. Veritas will map the planet's surface from orbit, using radar to uncover how Venus evolved over time. Europe and India are also preparing their own missions. Together, these projects could finally deliver what scientists have lacked for decades: direct measurements. They'll be able to analyze the concentration of phosphine, ammonia, sulfur, and water and determine whether organic molecules, the fingerprints of biology at some, are present. If they are, it would upend not just astronomy, but our entire philosophy of life. There's something poetic about all this. Venus, the planet named after the goddess of love, is in reality a world of fire and corrosion. Perhaps that's the irony of nature itself. Beneath beauty lies chaos, and within chaos hides a secret that refuses to die. Once we believed the sun revolved around the Earth. Later we believed Earth was the only world with life. Now we know the universe is far stranger than we ever imagined. And if somewhere within Venus's clouds tiny life forms truly exist, it would mean that life isn't the exception, it's the rule. The cosmos wouldn't be empty. It would be alive. And maybe our search isn't in vain. Because Venus also carries a warning: a planet once so much like ours, destroyed by its own atmosphere. It reminds us just how fragile the balance of life on Earth really is. In that sense, Venus isn't just a subject of study, like it's a mirror, reflecting us back at ourselves. We search for life in the universe, but perhaps the most important discovery will be here at home. If we can understand how Venus died, we might learn how to keep Earth alive.